students. Under the topic evaluation of integrals using Laplace transforms, here we have the third problem. The question is evaluate integral 0 to t e to the power negative 3t sine t dt by using Laplace transform. So now we have to evaluate the value of this integral by using Laplace transform, for which first we should write the definition of Laplace transform. So by the definition of Laplace transform, we know that Laplace transform of f of t is equal to integral 0 to infinity e to the power negative st f of t dt. So now we shall write the given integral in this format. So when we write so, we will rewrite the given integral as integral 0 to t e to the power negative 3t we will write in the front, and t sine t we will put it as one function and dt. So now when you compare this with the definition of Laplace transform, we see that the value of s is equal to 3, which we will substitute at the end of the problem. And f of t is equal to t sine t. So we can use the formula of Laplace transform. So this integral can be written as L of f of t. So at the place of f of t we are having t sine t. So we can write it as L of t sine t. Now let us mark this as equation 1, and let us evaluate L of t sine t separately, and then we can take and substitute over here. So we shall find that now. So now in order to find L of t sine t, we will be using theorem 2, which says that L of t f of t is equal to negative d by ds of L of f of t. So now when we compare these two, we can write L of t sine t to be equal to negative d by ds of L of f of t. So at the place of f of t, what do we have here? Sine t. So L of sine t. Now here we can use the result L of sine at, which says that L of sine at is equal to a divided by s square plus a square. So we are going to use this result over here. So what we obtain is, so L of t sine t to be equal to negative d by ds of, now L of sine t can be written as, the value of a is equal to 1. So it can be written as 1 divided by s square plus 1 square, which is 1. You can directly differentiate this with respect to s. You can also use u by v method. So if I use u by v method, this will be equal to negative, we will have outside, s square plus 1 the whole square in the denominator, and then b multiplied with u dash, differentiation of 1, which is 0, minus 1 multiplied with the differentiation of the denominator, which is 2s. So further simplifying, this will be equal to negative multiplied with, this will become totally 0, and here minus 2s divided by s square plus 1 the whole square. And so finally we will get this to be equal to, minus into minus becomes plus, so 2s divided by s square plus 1 the whole square. So therefore we have obtained L of t sine t to be equal to 2s divided by s square plus 1 the whole square. Now we have to take this and substitute in equation 1. That is, at this place we have to substitute. So after substituting, what we get is, so after substituting we get this, that is integral 0 to infinity e to the power negative 3t t sine t dt is equal to 2s divided by s square plus 1 the whole square. We already saw that the value of s is equal to 3. So now we have to substitute 3 over at the place of s. So put s is equal to 3. So what we get is integral 0 to infinity e to the power negative 3t t sine t dt is equal to, so when you substitute 3 here, we get 6 in the numerator divided by 3 square is 9. So 3 square plus 1 the whole square, which is equal to 6 divided by 9 plus 1 the whole square. 9 plus 1 is 10 and the square of 10 is 100. So 6 divided by 100. On cancelling and simplifying further, we get 3 by 50. Because 2 3 times and 2 50 times. So 3 by 50 is the answer. Therefore, we have evaluated the given integral. And we will write this integral as given in the question form. So therefore, integral 0 to infinity t e to the power negative 3t sin t dt is equal to 3 divided by 50. So this is the solution. Hope you have understood how to evaluate integrals using Laplace transform. Thank you.